Hello, Professor. This is Brian Coffin. This is Module 9, the last two lab experiments for the class. Give you a quick overview. For experiment 1, we had to measure the wavelength of a laser light. Experiment 2 was estimating the half-life. So that's just a quick overview of what we had to do. Safety. Safety is always a concern. For these two experiments, wasn't really anything too much to worry about for safety, except for the laser pointer, which we don't want to point in people's eyes. So I just made sure that we definitely kept that away from the eyeballs and focused on just getting the experiment done. So now we'll get into the results of the experiment 1. The wavelength with the laser light and the flashlight. Found this one to be a bit strange. The CD actually worked very well. Colors were very, I'm just going to turn the phone, were very bright and vivid. For the measurements, there's my measurements for the diffraction grader. I actually took the colored pencils and colored what colors I got in order top to bottom from the flashlight. Basically, it looks like a rainbow, very, very vivid rainbow. Then next we used the laser pointer on the disc, and all you get's still just a red dot. Nothing really special happens with that. So then we encountered using the diffraction grader. Started off with the laser pointer. I did use the box like suggested. What I got was red center dot with a faint dot to the left of it. Now when it came to putting the flashlight through the 1,000 lines, the diffraction grating still looked like normal light projecting onto the box. Basically a shadow and the light going through the box. Other than that, nothing special. Let me look at the paper again. Was the value obtained for the wavelength of the laser consistent with the range of the wavelength expected? I'm probably going to actually go with no on this. I think the values obtained are not consistent. Reason the error could have came from the fact that we didn't do multiple trials for each one to actually find the average. So that's what I think of that, and I actually did do the math, so you can see that. Next we will move on to present a properly formatted graph of your data table, and I'm going to pull that up on the computer right now. Hopefully it pops up. Maybe. Having a little technical difficulty with that, but I'll flip in the papers here and we'll go back to the estimating half-life until I'll talk while I try to get this pulled up. As you can see, here is the data. I started with 59 Skittles, all shaken, and it went to the 6th trial to get all 59 flipped, showing the half-life. Interesting way of doing it. There's my numbers. I'm pretty sure I did the total numbers right on the right column. Okay, I'm still having problems with this. I'm going to close it. Then I'll reopen. That way I got to be able to show you the graph. Give it a second to open. Okay, here we go. Here is the graph. So there's all my numbers I inputted. And as you can see, I did graph it out. At the bottom shows what lines are what. The parent atoms is in red. Daughter atoms is in blue. Actually, I thought with my trial, the half-life decay actually happened pretty fast. So there's the graph. I got to get moving. I'm going to run out of time. Critical thinking. Why did the spectra from the laser light and the flashlight different when reflected? I would say the spectra for the laser pointer and the flashlight when reflected from the CD surface, they're two different sources of light. I would consider the flashlight a black body radiation, while the laser is an incandescent bulb light. So I think that's the big difference between the two there. What is predictable about radioactive decay? Flip through my notes. When it comes to radioactive decay, what's predictable about it is the decay is radioactive decay is how long it will take for the half-life of the mass of the material to decay. What's unpredictable about it is that it is random and spontaneous, and how long a particular molecule takes to decay. So that's the predictability and unpredictability. Now, when it comes to self-reflection, the most useful in supporting your understanding of the content, I think that came down to basically the learning objectives of the work was the most useful for me. That way you knew what you were doing, and just so you can see, there's my Skittles and the cup I used to shake and roll. I didn't use the styrofoam cup in the kit because it was crushed. No surprise there. Most useful in supporting your growth in laboratory technique and or chemical safety. One thing that really helped me with it was reading the safety data sheets. Least useful for supporting lecture content, I didn't really have any. Least useful for supporting the development of your laboratory skills, I didn't really have anything. I really thought everything was very helpful. So, well, I guess this is the end of the labs, and we will maybe cross paths again in the future in another class. If you have any questions, please let me know. I will take a picture and I will send it to you through your email. Appreciate it, and thank you.